Today we start bounded set. Now A be bounded in a matrix space xt if there exists x0 belongs to x and r greater than 0 such that A subset of bx0 r. Okay, that means A belongs to A is subset of one open ball of center x0 and radius r. Okay, then we going to further discussion of one problem. This problem is, we write this problem first. Okay, a subset A of a matrix space xt is bounded if and only if for every x belongs to x there exists r greater than 0 such that a subset of bxr. Okay, now we are going to prove of this problem. Okay, first we understand this one. Just a subspace is bounded, that means one set is bounded, and here this subset, okay, this subset of x is bounded if and only if this happens. How this happens we now discuss today. This one we know about that a subset of x and a bounded implies that there exists x0 belongs to x and obviously one r greater than 0 such that a subset of bxr. Okay, and then we start again. For every x belongs to x there exists r greater than 0 such that a subset of bxr. Okay, this one is given. Now a be bounded we have to prove. Okay, then we choose a fixed point x0 belongs to x such that x equal to x0, then a subset of bx0 and here r. Okay, for r greater than 0, then what we obtain? We erase our portion. Then we obtain a subset of bx0 r greater than 0. Then this implies that a be bounded on x. Okay, so we do this problem. That means a subset is bounded if and only if for every x belongs to x there exists r greater than 0 such that a subset of bxr. For every x, why? because x0 here arbitrary and here also x is arbitrary, so any x we construct, then r's are different. Any x, for any x we choose a r greater than 0, for that a be bounded. Okay. So 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 for each x, any x, for each x we choose a r. Okay, we choose different r, we choose different r greater than 0, for that or such that this one. Okay, a be bounded. So we going to this, we also do this problem. Next we going to another one. Okay, another one is the union of finite number of bounded set in a matrix space be bounded. We write this problem first, then we do or we solve this, then we write this problem. Okay, so that so that the union of a finite number of bounded set, union of a finite number of bounded set, union of a finite number of bounded set in a matrix space, in a matrix space be bounded. Okay, so that the union of a finite number of bounded set in a matrix space is bounded. Okay, how we do this problem? Okay, we also known about that a1, a2, a1, a2 dot an, we finite number of bounded set. Then ai subset of bxir for r greater than 0. Okay, or any problem here? I think not a problem. Okay, or we fixed one x0, then it is fixed xi. Okay, where xi belongs to x and r greater than 0, and this one hold. So union of finite number of bounded set, that means union of ai subset of union of bxir. Okay, then this bxir is here I equal to 1 to n, here I equal to 1 to n, each bxir be open. So union of finite number of open set be open, finite number of open sets be open. Then union of I equal to 1 to n, union of I equal to 1 to n bxir obviously equal to b something x0 r, where x0 belongs to x be fixed and r greater than 0. Okay, then what we find? We find that we erase this portion, then we find that union of I equal to 1 to n ai subset of bx0 r. so so union of I equal to 1 to n a I be bounded. Okay, next we erase this board and this portion. Now we're going to further discussion about this definition. Okay, now let A be a non-empty subset of a matrix space XT. Let A be a non-empty subset of a matrix space XT, and the diameter of A is defined by diameter of A equal to supremum of txy such that xy belongs to A. Okay, in the extended real number system, in the extended real number system. Okay, now then what we find? We find the diameter definition of this diameter. Okay, diameter equal to supremum of txy. Next we going to the another problem. This problem is that the diameter of one open ball less than equal to 2r. Okay, diameter of one open ball bxr, okay, less than equal to 2r. How this one is proved? This one is too easily we handle. Diameter of bxr equal to supremum of dyz, where yz belongs to bxr. Then this yz belongs to bxr. Okay, this yz belongs to bxr, and dyz equal to how much? Those are, if these are the, that means supremum of dyz equal to, if we choose this one, supremum of less than equal to dyx plus dx. Okay, since y and z are belongs to bxr. Okay, then this one is happen, yz belongs to bxr. This less than equal to, or this equal to, less than equal to supremum of r plus r, okay, equal to 2r. Then what we find? We find that diameter of bxr less than equal to 2r. Okay, this one equal to 2r. Oh, this implies that diameter of bx are less than equal to 2r. Okay, now we're going to another problem. We erase these portions. Now we're going to another problem. This problem is a subset is bounded if it is empty or its diameter is finite. Questions: a subset A is bounded if and only if it is empty, or its diameter of A is finite. Okay, then what we do this problem. It is empty. That means if A equal to phi, then A be bounded. Trivially, since A subset of bxr, okay, Rx belongs to x. Now if A not equal to phi, then diameter of A equal to supremum of dxy such that xy belongs to A. Okay, and this one A be bounded. Okay, A be bounded, or this one be finite. That means A be bounded. Okay, this one less than finite means less than infinity. Then dxy less than plus infinity. This implies dxy less than m or m greater than 0. This implies x belongs to bym. Okay, now x is arbitrary, so x belongs to A implies that x belongs to bym. So then A subset of bym. Okay, then diameter finite means this implies that A be bounded. Okay, now obviously conversely, if A be bounded means this one hold, this one hold means this one hold, this one hold means this one hold, this one hold means this one hold. That means if we back this arrow in this way, then obviously diameter of A equal to less than plus infinity. Okay, so we prove this problem. That means a subset A is bounded if either it is empty or its diameter is finite. Okay, now we erase our portion. Now xn be a convergent sequence in a matrix space xt. Let xn be a convergent sequence in a matrix space xt. We have to show that xn be bounded. We have to show that xn be bounded. Now convergent sequence, then this one is bounded. How this one is formed? This one xn converges to x. Okay, xn converges to x implies that d of xn x less than epsilon or epsilon greater than 0. This implies that xn or x minus epsilon less than xn less than x plus epsilon. Okay, this implies that, okay, here for all n belongs to n, or for all n greater than equal to k belongs to n. Okay, then this xn, okay, this xn belongs to bx epsilon. Okay, now since xn converges to x and x be fixed, then the set xn, then the set xn, okay, be bounded. Since xn this one, this implies that xn subset of bx epsilon, or x belongs to x. Okay, so we have this problem, and we, that means we have done this one, is happened. Now if convergent, then this one is bounded. Okay, and similarly if Cauchy, then this one is bounded. xn be Cauchy, then the set xn is bounded. Okay, xn be Cauchy, then the set xn is bounded. Now xn be Cauchy, then the set xn be bounded. Okay, xn Cauchy means d of xn less than epsilon for epsilon greater than 0, and for all n m greater than equal to k belongs to n. Okay, now this implies that xm minus epsilon less than xn, and here n greater than m. Okay, less than xm plus epsilon. This implies that xn belongs to bxm epsilon. Okay, now 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 for this one, xn belongs to this, then xn belongs to bxm epsilon for all n m greater than equal to k, n greater than m, and k belongs to n. Okay, and epsilon greater than 0. Then the set xn is bounded. Then xm be fixed, so xn set subset of bxm epsilon greater than 0. So the set xn be bounded. Okay, now so we do another problem. Okay, we erase these portions. Now X norm be a non-linear space. We have to show that a subset of X be bounded if and only if there exists m greater than 0 such that norm of X less than equal to m. Okay, now what we do, if a be bounded implies that bounded subset of X, then there exists there exists m greater than 0 such that a subset of b 0m. Okay, if we construct if we construct 0 belongs to a, okay, then this one is possible or not possible. Okay, then x belongs to a implies that x belongs to b 0m. This implies x difference 0 norm of this less than equal to m. This implies norm of x less than equal to m. Then a subset of x be bounded if there exists m greater than 0 such that norm of x less than equal to m. Okay, next we're going to which vector subspace of a non-linear space are bounded. Only the zero subspace, only the zero subspace of a non-linear space are bounded. Of a non-linear space are bounded. Otherwise, if W be a non-zero subspace, if W be a non-zero subspace and 0 W belongs to W, then TW belongs to W for any T belongs to R. Okay, so only the zero subspace of a non-linear space are bounded subset. The set On of all orthogonal matrices is bounded subset of M in R. Okay, the set On of all orthogonal matrices is a bounded subset of M in R. Now A equal to A1 A2 dot 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 AN. belongs to ONR, where AI is the ith column, where AI is the ith column. Then AI is equal to this one. Have we considered AI as column vectors in array. Okay, where AI is equal to delta ij and where AI as the column vector in Rn, then then hence norm A square equal to summation I norm of AI square equal to n. Okay, then then we found that the set of orthogonal matrices is bounded subset of M in R. Okay, now we're going to SLNR of all n cross n real matrices with determinant 1 is not bounded in MNR. The set SLNR of all n cross n real matrices with determinant 1, real matrices with determinant 1 is not bounded in MNR. Okay, for n greater than equal to 2. Then what happen if we construct SL2R? Okay, then with at least one entry arbitrarily large, with at least one entry arbitrarily large, arbitrarily large, then the set of all 2 cross 2 matrices with determinant 1 is not bounded in M2R. Okay, so today we stop here.